Hey, what's up guys, Jeremy here. Today, let's learn how you can synchronize multiple robots within a RoboDK station. Let's get started. This is a question I get asked often. How can I synchronize multiple robots within my station? So let's see how we can do that. First, open the robotsync.rdk here, and you can run the main program here to just see what we are trying to achieve. So in this case here, we have two simple robots, so two RB120, and each robot is waiting for the other one to finish its motion before starting its own motion. So it's kind of a I move, you move, I move, you move, and we all kind of catching up with each other. So that's one way of synchronizing things. There's other ways, but this is what I'm going to show you today. So I'm going to stop that here, and we're going to create two simple programs. So I won't create the three targets. Let's say it's just going to be a bit longer for reasons. You can take a look here at rob1 prog and rob2 prog if you want to see the triangle. So I'm going to create a program here, and I will do the same for the second robot. So create program. I will call it prog rob1, and here prog rob2. First of all, we have an init here. We'll use the same init. So the init is set rob reach pause 0, set rob2 reach pause 0. So I created some variables or some IOs that I called rob1 reach pause to just either the robot has reached the pause or it hasn't reached the pause. So the main program would look something like that. If I select those three like that, right click, create main program. We will call it test here. So just to have another different name of this as this one here. And I want those two programs here to run in loops. And I would like those two here to be threads so that they can run indefinitely in loops. Okay, cool. So now that I have that, if I was to run that here, they would just be unsynchronized, and I purposely made one robot way faster than the other, so this way we can see if it doesn't work, in fact. Okay, so the goal here is to kind of create some kind of handshake, meaning like let's say this one here is moving, it reaches its position, the other one moves, reaches its position, then this one moves, reaches position, then this one moves, reaches position, and so on and so forth. So what you can do here is start by adding some set and some weight. So we'll consider that the robot 1 here is the master and this one is the slave. So this one will have kind of the hand to begin with. So I will add a set here instruction, modify, Control V, I have here robot 1 reach position. So when the path is finished, it will read the position. So I'm going to click OK. I'm going to Control C and then Control V that here. Here to say that this one here reached its position. This is going to be pretty much the same thing for this one here. Instead, that I'm going to modify here rob1 and make it rob2. So this is for when they reached their position. And on the other hand, as soon as they try to restart, or as soon as I'm about to move, I need to make the reach position false here. So just like that here, I could have put it here, it would have been the same. In this case here, I just need to make it here, modify to here, click OK, Control C, Control V. So pretty much what I'm doing right now, I'm not having any handshake, I'm just sending a signal to say, okay, I reached my position, I'm about to move, I'm moving, I reached my position, I'm about to move, I'm moving, I reached my position. Same here, I'm moving, I reached my position, I'm about to move, I'm moving, I reached my position, I'm about to move, I'm moving, I reached my position. So now we need to add the weight. So if I right click here, add instruction, set weight instruction, set IO instruction, I can go and select weight. I can go and Control V, oops, not this here, Control V. Here, this one will be waiting for rob2. So it's always a matter of waiting for kind of a rising edge. If you are familiar with automation, you're not waiting for the signal to be there, you're waiting for the signal to appear, because otherwise the signal might still be there from the last time it was put at once. So what you want now is looking for a rising edge. So I'm going to go and reach position 0, Control C, and then Control V, modify 1 here. So just make sure that I'm not saying anything stupid. Yes, exactly. Control C, and then here, same thing, Control V. So I'm looking for the rising edge. Here, Control V. Oops, Control. Delete. This time here, I'm looking for the rising edge, but on the first one. Here on the first one, Control C, and then Control V, just to make sure that I'm not. And I should be able to live with that here. 0 set, so the set here should be 4. We'll try that. We'll see if it works. Here we're waiting for. So we have a pause here. We're waiting for robot reach position 1, and here we don't have it, and the robot here too didn't reach position 1. So for sure we don't have it. This one is waiting for this here. So if I just... Here we have an in synchronization. We are not waiting for the right spot. So I'm just going to go look at my example and see here what I'm missing. Here we have a wait rob1 reach 0, wait rob1. Okay, so I was... Control C here, Control V. So this one here needs to be modified to 0. And here I need to, Control C here, set this at 0. And here we are waiting for reach pause 0, reach pause 1, set pause 0. So that's fine. And then at the end, okay, here this shouldn't be there, and here let's compare those two here. So here we have the set, and then wait set 0. Okay, so let's try this one here. Perfect. So now we have kind of a synchronization between those two. So that's one thing we can do with the synchronization. Another thing that I like doing with that, and it's going to appear here in the depalletization, is if I have a zone here, let's say I have two robots and they need to depalletize those pallets here, and I can't just run the program as is. Otherwise, those two robots might collide in between here. So what I'm doing is kind of creating a zone here that I'm reserving or kind of locking for one robot at a time. So if I go main program, you see both robots have boxes in their hands, but they will wait in their, let's say, retract position here up until the other robot kind of release the zone. So they're kind of, I take the zone, then I release it so you can take it. I take the zone, then I release it so you can take it. Replace object. So the way it works is I have here call rob1 init, call rob2 init. So if I take a look at rob1 init, it's just set rob1 conf1 and then set rob2 conf2 conf0. So that means that rob1 has, or rob1, I don't know which one is rob1, rob2 here. rob1 has the priority to be the first one here. And if I look at the main here, I have rob1 depalletizing and rob2 depalletizing. And here I will set here rob1 conf at 0, so I don't need every time I'm kind of moving out of the zone, I will release the zone. If I look at the it was in rob1 vacuum or rob1 drop conveyor. Rob1 drop conveyor. I will wait for Rob2 conv to be 0, so I will wait for the Rob2 to release the position. Then I will set, okay, I'm taking control of that zone. I'm doing whatever I have to do here. And then as soon as I'm out, I'm releasing the zone again. So here, as soon as this one is done here, I'm changing reference frame. I'm doing a motion towards my approach here. And then I'm setting the zone at 0 again for the next robot to be able to take on and take that zone here. So this way I'm certain that I won't have any collisions between the two robots. Okay, that's pretty much everything for this video. I hope it was helpful. In the next one, we will talk about the replace object feature, replace robot feature, sorry, that will let you create a program with one robot and then use another robot with the same program very quickly in just a matter of a few clicks so that you can test the same project with multiple robots to see which robots you want to use for your project. I hope to see you there. In any case, have a great day, guys.